Hi, welcome to my channel. Today we are going to discuss about tanh activation function or hyperbolic tangent activation function. The tanh function is mathematically defined as tanh x equals to e to the power x minus e to the power minus x over e to the power x plus e to the power minus x. If we look at its graph, we can see that tanh smoothly maps the input values into the range -1 to +1. For large positive inputs, the function saturates at +1, and for large negative inputs, it saturates at -1. The derivative of tanh function is given by d of x of tanh x equals to 1 minus tanh square x. This derivative is highest around 0, which helps learning when the inputs are in this region. Intuitively, tanh can be viewed as a stronger version of sigmoid function. Unlike sigmoid, which outputs values between 0 and 1, tanh is zero-centered, meaning its output is symmetric around 0. The zero-centered property leads to better gradient flow during training and generally results in faster convergence compared to sigmoid. However, tanh is not without limitation. For very large positive or negative inputs, the function still saturates, causing the vanishing gradient problem, especially in deep networks. To summarize, the tanh activation function provides better performance than sigmoid due to its zero-centered output and stronger gradients, but it still suffers from saturation issues. This limitation motivates the use of activation function like ReLU, which will be discussed next. Thank you.